Today we're going to work on the fall midterm review for PreCalculus. This midterm review is going to reflect the items that are going to be on the actual midterm exam itself, which will happen later this week. It appears we've got 10 problems to work through today. So let's begin with number 1. Find the equations to lines that are parallel and perpendicular to the line y equals negative 3x plus 1 and pass through the point 2, negative 5. Okay, so let's pause here. Parallel and perpendicular. Parallel lines have the exact same slope. So I'll make myself a little note here. This is same slope. And perpendicular, this is the one that I think flip and switch. I want to take the original slope here, flip it upside down, switch the sign. So I'll make myself a note here, flip and switch. Okay, what else do we have? It passes through the point 2, negative 5. So this is my x1 and my y1. All right, I think I'm ready. Let's start with parallel. The first thing I'm going to do is use point slope form. That's y minus y1 equals m times the quantity x minus x1. Well, here I'm going to plug in x1 and y1. x1 is 2, y1 is negative 5, and the slope I want to use is negative 3 because remember, parallel lines have the exact same slope. So let's plug in y minus y1 is negative 5. And this is equal to m is negative 3. Times the quantity x minus x1 is 2. All right, so this is y plus 5 is equal to, and then I can distribute this through, negative 3x plus 6. Lastly, let's subtract 5 from both sides. And a line that is parallel to y equals negative 3x plus 1 passing through this point will be y equals negative 3x plus 1. Okay, what about something that is perpendicular? For this, I need to flip and switch my original slope. Now we'll call this m1. m1 is negative 3, which as a fraction is negative 3 over 1. That means that m2, the slope I actually want to use, I'm going to take this negative 3 over 1 and I'm going to flip it upside down, so that'll be 1/3. And then I switch the sign, so I'm going from negative to positive. The slope here is going to be 1/3. I'm still going to plug in x1, y1 into my point slope form, and I can do that right here. So we've got y minus y1 is negative 5. And this is equal to m now is going to be 1/3 times the quantity x minus x1. So x minus, and then x1 is 2. All right, let's clean this up. We've got y plus 5 is equal to 1/3 x, and then minus 2/3. We'll multiply this 2 to just the numerator of 1/3. Okay, so now I've got to subtract 5 from both sides. Except instead of subtracting 5 as 5 over here, I know that this fraction has a denominator of 3. So I'm going to subtract 15 thirds from both sides. 15 over 3 is the same as 5. All right, so y equals 1/3 x, and then negative 2/3 minus 15 thirds. This will be minus 17 thirds. All right, number 2. Evaluate f of x equals 3x squared minus 2. I'm going to evaluate this for f of 0, and I'm also going to evaluate this for f of t plus 1. So for f of 0, this is going to be 3 times 0 squared minus 2. Well, 0 squared is 0. 3 times 0 is still 0. That whole thing's going to be 0. So f of 0 equals just 0 minus 2, or negative 2. What about f of t plus 1? This means instead of x, I'm going to plug in t plus 1. This will be 3 times the quantity t plus 1. This is squared, and then minus 2. Well, t plus 1 squared, I'm going to multiply that with a box. Let's do that over here. That means I'm going to do t plus 1 here and t plus 1 here. That is a t squared plus 1t, or just plus t, plus another t, and then plus 1. Putting this together, combining like terms, t squared plus 2t plus 1. So t plus 1 squared is this, t squared plus 2t plus 1. So let's replace that. 3 times the quantity, t squared plus 2t plus 1, and of course still minus 2 at the end. And then we'll distribute this 3 through. Three t squared plus 6t plus 3, and then minus 2. Well, 3 minus 2, I can combine that to be 1. So let's do that. This 3 minus 2 will be 1 plus 1. Moving right along. It says, consider the following functions for problems 3 through 6. F of x equals negative 3x plus 2, and g of x equals 2x squared plus 5. For number 3, I'm going to add these functions together. For number 4, I'm going to multiply. For 5 and 6, I'm doing function composition, where f is going to be my base function, and I'm going to plug g in for 5. And for 6, g is going to be my base function, and I'm going to plug in f. So let's start with number 3. Let's add these together. So when I'm adding these two functions together, I've got to be really careful, and I want to make sure that each term has its own column. What I mean by that is x squareds are all in one column, x's are all in one column, constants are in one column. Let's see what that looks like. Negative 3x plus 2 is my first function. Let's put that here. And to that, I'm going to add g of x is 2x squared plus 5. Okay, 2x squared. I'm going to put that to the left right here. And then plus 5, I'm going to put under the plus 2. Now, the reason I'm doing this is so that I can put in some placeholders. In the top, I've got 0x squared, then minus 3x plus 2. And in this one here, I've got 2x squared plus 0x, and then a plus 5. This just helps me when I'm actually going to add things together. Otherwise, if I just put them anywhere, I might get confused when I'm actually going down to add. Okay, so 0x squared plus 2x squared, this is going to be 2x squared. Negative 3x plus 0x is going to be negative 3x. And then 2 plus 5 is 7. So f plus g is 2x squared minus 3x plus 7. All right, now let's do f times g. F times g, so these two things multiplied together, let's use a box. And we'll put negative 3x plus 2 along the top. And down the side, we'll do 2x squared and then plus 5. All right, for each of these, we'll multiply 2x squared times negative 3x is negative 6x to the third. 2x squared times 2 is going to be 4x squared. 5 times negative 3x is negative 15x. And 5 times 2 is 10. Let's put this all together. Negative 6x to the third plus 4x squared minus 15x plus 10. All right, f of g, this is function composition. The left function, so we see f here, this is going to be our base. So let me write that down. Our base is going to be f, which is negative 3x plus 2. And what I'm going to do is I'm going to plug in g in for x here. So g is 2x squared plus 5. This will end up looking like this. Negative 3, and then instead of x, plugging in 2x squared plus 5. And then I still have this plus 2 at the end. Well, let's distribute. Negative 6x squared minus 15, and then plus 2 at the end here. This is going to make negative 6x squared minus 13. And last one on the first page, g of f. This is another function composition. This time g is going to be our base, and we're going to plug in f. So let's write that down. The base here is going to be 2x squared plus 5. And for x, we're going to plug in f negative 3x plus 2. So this will be 2 times the quantity, negative 3x plus 2. We're going to square that and then add 5. Well, since I'm squaring this negative 3x plus 2, that means I'm really using a box here. So let's make another box over to the right here. And this will be negative 3x plus 2 along the top and down the side. And let's multiply through. So negative 3x times negative 3x, this is going to be positive 9x squared. Negative 3x times 2 is negative 6x. I've got another negative 6x right here. And 2 times 2 is 4. So this is 9x squared minus 12x, and then plus 4. So this is going to replace negative 3x plus 2 squared. 2 times the quantity, 9x squared minus 12x plus 4, and then a plus 5 at the end. Let's distribute. $18x squared minus 24x plus 8, and then plus 5. Well, I can actually combine some terms here, this plus 8 and this plus 5. Let's combine those together. That's going to make 13. So replacing that, that'll be 18x squared minus 24x, and then plus 13. And let's move on to the second page. All right, on the back, I'm working with some quadratics. In particular, these are going to be things I want to find in standard form. So for the first one, describe the graph of the function and write the function equation in standard form. F of x equals a times the quantity x minus h squared plus k. Here my function is f of x equals x squared plus 6x plus 3. Okay, for this problem, what we have to do is a method called completing the square. So that involves separating my x terms from everything else here. So I'm going to put the x squared plus 6x in some parentheses. And then what I need to do from this, from here, is add b over 2 squared as well as subtract b over 2 squared inside these parentheses. So that's b over 2 squared. Well, a is 1, b is 6, and c is 3. So for this, that'll be 6 over 2 squared. Well, 6 over 2 is 3, so this is 3 squared. 3 squared is 9. So that means I'm going to write x squared plus 6x, and then I'm going to add 9, subtract 9, and have a plus 3 at the end. Now, because I didn't factor out a monomial, I can really move this parentheses around. This is intended for if I pull out like a 2 or a 3, then I have to distribute that 2 or 3 back into all of the items, and then I would separate that distribution. Since a is going to be 1 here, I can actually just move this parentheses right here. And what we'll see is that this trinomial, x squared plus 6x plus 9, is a perfect square trinomial, hence the complete the square. And a perfect square trinomial will always factor to something that looks like this, a set of parentheses that's squared, and inside you'll get the square root of your first term, so square root of x squared is x, and the square root of your last term in this perfect square trinomial, so the square root of 9 is 3, and then the sign in the middle gets copied. So x squared plus 6x plus 9 is the same as x plus 3 squared, because this is what it would factor to. Then over here, I've got negative 9 plus 3. Well, negative 9 plus 3 is negative 6. This is the standard form. So I can say f of x equals x plus 3 in parentheses squared minus 6. And from here I can tell a few things. Firstly, this coefficient a is positive. Now we don't see it, but it's a positive 1. Being positive, it means that this is going to open upward. The parabola will open upward. If it were negative, it would open downward. The vertex, well, h is going to be right here, and k is going to be right here. My standard form is really x minus h and then plus k. Another way to think of this is opposite, same. So my vertex is going to occur at the opposite of this plus 3, that's negative 3, and the same as what I see over here, negative 6. So my vertex is going to be the point negative 3, negative 6. To find the x-intercepts, what I'm going to do is set my standard form equal to 0 and solve for x. So let's do that starting right here. X plus 3 squared minus 6. We're going to set this equal to 0. Well, let's begin by adding 6 to both sides. And we'll get x plus 3 squared is equal to 6. And from here, let's take the square root. Taking the square root, x plus 3 squared, well, the square root of something squared is just that something. So this will be x plus 3 is equal to, and because I'm taking the square root, a variable is involved, I've got to remember to do plus or minus, and then the square root of 6 here. Let's subtract 3 from both sides. And we'll get x equals negative 3 plus or minus the square root of 6. Now what I want to do is write something in standard form given the vertex and a point that it passes through. So in this one, I recognize that my vertex, 2, negative 4, this is h and this is k. So let's write that down. This is h and this is k. And it passes through the point 5, 5, which means that at this exact point, this is my x and this is my y. So my standard form says f of x equals a times the quantity x minus h squared and then plus k. Well, let's fill in what we know. F of x, this is just fancy for y. So this will be 5 equals, a is unknown to us right now, and then x minus h. So that's going to be 5 minus 2. We're squaring this, and then plus k at the end. Well, k is negative 4, so we'll say minus 4. Okay, 5 equals a times 5 minus 2 is 3, so this will be 3 squared minus 4. 3 squared is 9, so 5 equals 9a minus 4. We can add 4 to both sides. To get 9a equals 5 plus 4 is 9. And then dividing both sides by 9. Careful here. I know a lot of people are tempted to just put 0 because it canceled. But 9 divided by 9, a equals 1. So now my standard form, remember, it's f of x equals a times x minus h squared plus k. I need my f of x and I need my x. So I'm going to plug in my a, my h, and my k, and it's going to look something like this. F of x equals a is 1 times the quantity x minus h, so that's going to be x minus 2 squared, and then plus k, well, k is negative 4, so minus 4. Okay, 2 more problems. Number 9, this is long division. Okay, use long division to show 2x plus 1 is a factor of the function f of x equals 2x to the third minus x squared minus 5x minus 2. Write the result and find all factors. Okay, well, if we're using this to show 2x plus 1 as a factor, I can immediately say that 2x plus 1 is one of the factors. Okay, now I just got to find the rest of this. So let's do some division. I'm going to put this under a division sign. 2x to the third minus x squared minus 5x minus 2. This will go under there, and on the outside, I'm dividing by 2x plus 1. Okay, I've got 4 steps to follow, and I'm going to repeat those steps until I get to the very end. So step 1, divide the first term on the inside by the first term on the outside. 2x to the third divided by 2x, that is going to give me x squared. So x squared is going to go right here. Step 2, I'm going to take this x squared, I'm going to multiply it to all the terms on the outside and write that underneath. So x squared times 2x, that's going to be 2x to the third. X squared times 1 is going to be x squared. Step 3 is to subtract. So I'm going to subtract these, and you'll notice that 2x to the third is going to subtract 2x to the third. These should always match because these are going to subtract out. What are you left with? Negative x squared minus x squared is going to be negative 2x squared. And step 4, we're going to bring down the next term and start back at the beginning. So bring down minus 5x and go all the way back to step 1. Divide the first term on the inside by the first term on the outside. Well, the first term on the inside is now negative 2x squared, and I'm going to divide by 2x. So that's going to give me negative x. Step 2. Take this and multiply to all the terms on the outside. Negative x times 2x is going to be negative 2x squared. Negative x times 1 is going to be negative x. Step 3, subtract. These two are going to match because they need to subtract out. And what am I left with here? Negative 5x minus an x is negative 4x. Bring down the next term and begin anew. Step 1. Take the first term on the inside, negative 4x, divide by the first term on the outside, 2x. Negative 4x divided by 2x is going to be negative 2. Take this negative 2, multiply to all the terms on the outside. That'll be negative 4x. Negative 2 times 1 is going to be negative 2. Step 3, subtract. And lo and behold, when I do this, these all subtract out, leaving 0 behind as a remainder. That's good because 0 as a remainder indicates that 2x plus 1 is in fact a factor. When I divide 2x to the third minus x squared minus 5x minus 2 by this 2x plus 1, the result of this is x squared minus x minus 2. The last thing I have to do is find all the factors, meaning take this x squared minus x minus 2, and we are going to factor this. A equals 1, c equals negative 2. All the things that multiply to get 1, well, that's easy enough. 1 times 1. Things that multiply to get negative 2, 1 times negative 2, and 2 times negative 1. And what I'm going to do here is try to find the correct set of binomials that would multiply to get back x squared minus x minus 2. Because a equals 1, I do have a trick here. I can just add my factors of c to see which one would give me a negative 1. Looks like 1 plus negative 2, that would give me a negative 1. So 1, 1 means 1x, 1x. 1, negative 2 means plus 1 on the left, minus 2 on the right. These are your other factors, and we're going to write them right here. Last problem, use synthetic division to divide the function 3x to the third plus 5x squared plus x minus 7 by x plus 4. We're going to write the result along with the remainder if it exists. So for this, we set this up a little bit different. We're going to make this upside down. There's going to be 2 rows in here. The top row, these are going to be the coefficients of your terms. So I've got 3 for 3x to the third, 5 for 5x squared, 1 for 1x, and then minus 7. Then what I put over here, this is not going to be x plus 4. In fact, what I need to do is say x plus 4, set this equal to 0, solve for x, subtract 4, and I get x equals negative 4. I'm going to put negative 4 over here and bring down the first term. Then it's a 2-step process. I'm going to multiply diagonally and add straight down. So negative 4 times 3. Multiply diagonally, that's going to give me negative 12. That goes right here. Let's add straight down. 5 plus negative 12 is negative 7. Multiply diagonally, now negative 4 times negative 7 is going to give me positive 28. Add straight down, that makes 29. We're going to multiply diagonally. Negative 4 times 29. This is, let's see, negative 116. And then we're going to add straight down. I like to do this last one in a different color. Negative 7 plus negative 116 is negative 123. Why am I doing this a separate color? To indicate that this is my remainder. My answer, well, my highest power that I started with was x to the third. I'm going to drop that down 1, and I get 3x, drop that down by 1, squared, and then keep dropping it down by 1, minus 7x plus 29, plus a remainder of negative 123 over, what did I actually divide by? X plus 4. All right, that is the entire test review. Hopefully that will help you out. Please study up for the exam.